One line change to a prompt broke 7 out of 23 evaluations, but it was caught in continuous integration and not production. You know that feeling. You tweak a prompt to fix one edge case, ship it, and 3 days later someone pings you saying a totally different flow is broken. Unit tests passed, nothing crashed. Today we are building the eval pipeline that catches this stuff before it ever gets near production. So LangSmith evaluations basically work like this. You have a golden dataset. That is just a curated set of inputs with expected outputs. Every time your agent changes, you run it against the whole set. Custom evaluators score each run on stuff like accuracy, tool use correctness, and relevance. Now you can see exactly which cases got worse and by how much. Alright, the pipeline has 3 pieces. The golden dataset lives in LangSmith. The evaluators are just Python functions we write ourselves, and pytest runs them on every commit. Notice that each custom metric returns a score between 0 and 1. This makes regression detection basically trivial. And the cool part is that Pydantic gives us structured outputs so the scoring stays consistent across runs. Enough theory, let's build it. Let's get the project set up. We need LangChain for the agent builder, langgraph as the runtime underneath it, LangChain OpenAI for the model, LangSmith for evals, Pydantic for structured outputs, pytest to run the suite, and pandas to support running the tests. The next step is to create the .env file and put our environment variables here. We have the OpenAI API key and the LangSmith variables. Now inside the agent.py we define the agent that we're going to evaluate. We are using create agent from LangChain agents, which is the new replacement for create React agent. Same React loop underneath, cleaner API on top. It's a basic agent with 2 tools, weather lookup and stock price. In a real project this would be way more complex, but the point of this tutorial is the eval pipeline and not the agent itself. Notice that the 2 docstring matters here. The model reads them to decide which tool to call. That is actually what our tool use evaluator is going to check later. If the agent picks the wrong tool, we want that called automatically. Now inside the dataset.py file, we define the golden dataset we talked about. Each example has an input question and the expected answer plus which tool should have been called. The expected tool field is what lets us score tool use correctness later. We're keeping it to 3 examples for readability. In practice, you want 20 to 50 cases covering your real use cases. The key thing is that this example should reflect what your users actually ask and not just the happy paths. Once this runs, the dataset lives in LangSmith and every future eval pulls from it. Next, inside the schemas.py file, we define the schema for the accuracy evaluator. We are using an LLM-as-judge and without structure it would hand us back mushy text. Pydantic works the output to a float between 0 and 1 plus a reasoning string. That way, scoring stays consistent and regressions become easy to spot. Next, inside the evaluators.py we're going to define our evaluator functions. Here is the first custom evaluator. It uses an LLM-as-judge to score how close the actual answer is to the expected answer. Notice the with structured output call. That forces the judge to return a Pydantic object and not free text. Now every accuracy score is a clean float between 0 and 1. The function signature matters too. LangSmith passes in the return and example automatically and we return a dictionary with key, score and optional comment. That dictionary shape is what shows up in the dashboard. The next evaluator is deterministic. There is no LLM judging, just a straight check. We pull tool calls out of the agent's message history and see if the expected tool is in there. Score is either 1 or 0 and there is no middle ground. And you can notice the defensive parsing here. Depending on the provider, tool calls can come back as a dictionary or as an object, so we handle both. This is actually the evaluator that catches the snap hook scenario. A prompt change that makes the agent skip tools will fail this test immediately. That is why custom evaluators matter. The quality dimensions you care about are almost never in a pre-built metric. Alright, this is where the pipeline actually becomes CI ready. The run agent function wraps our agent so LangGraph can call it with each example. Then evaluate runs the full dataset against both evaluators. The assertions at the bottom are the regression gate. If average accuracy drops below 0.85 or tool use drops below 0.9, pytest fails. Your deploy pipeline fails with it. Notice that we are using means here and not pass-fail per example. Some noise is normal, but to drop across the whole dataset is a real regression. Alright, before we do any testing, we need to push our golden dataset to LangSmith. For that purpose, we are going to execute our dataset.py file. And as you can see, our agent golden set was created with 3 examples. Now let's run our test agent evals file and see what happens. Fantastic, you can see that our test agent regression passed. Now we can go to the LangSmith dashboard and see it there as well. This is the dashboard for our agent golden set. You can see our experiment run here. Let's check what we've got. We've got 0.95 accuracy and 1 on the tool use. You can check the latency, the tokens that were used, the associated cost, and the error rate. Let's now check the experiment specific things. You can see our 3 inputs and the 3 expected outputs. You can compare them with the actual outputs from the agent. Here you can see the average accuracy that was scored for each execution. You can also see how many tokens each invocation consumed, what was the latency, and what was the cost. Alright, let's look at what you've got now. A golden dataset of curated test cases that represent what your agent should actually do. Custom evaluator functions scoring every run on accuracy, tool use correctness and relevance, and pytest wired up so every commit triggers the full suite automatically. Basically no more shipping a prompt change and finding out 3 days later that you broke something. You can see the regression the moment it happens, on which case and by how much. Next step, add your own domain specific evaluators. Start with the metrics that actually matter for your use case. And if you want more stuff like this, hit subscribe. I'll catch you in the next one.